You're watching CTOM TV. Knowledge is power.
I have a question for Alex here. I used to be a histology technician, and I'm wondering how, of course, I've long retired, but I'm wondering how a lab would need to receive a tissue to send it for genetic testing. Obviously, you can't just put it in formalin like you can a histology specimen.
Yeah, I think that's an excellent question. So, we're still stuck with FFPE for most, tissue blocks and slides and so on. What is really important that we understand now for precision oncology and genetic testing, and specifically, is the preservation of the RNA and the DNA. And FFPE doesn't preserve RNA and DNA that well. So the two technologies that we're now using is we're using there's a new technique that uses a laser beam to extract and separate the tumor cells from the biopsy sample. And so it's a little expensive right now compared to standard microscope-based pathology, but it definitely allows us to access a much higher concentration of tumor cells from a poor sample that may only have 20-25% tumor cell in the tissue. And additionally, when it comes to next generation sequencing, which is the tool that is now used for determining your RNA expression or what mutations you have, it's really the basis of precision oncology is what we call next generation sequencing. There's two different approaches to it. One is called a hybrid capture technique that was developed by a company called Illumina. And that's really the standard for many, many years. Recently, there's been what's called a PCR-based approach. So the hybrid capture is really good for getting samples that are at a very low percentage, whereas the PCR-based is very good at getting a sample that is degraded. So if the DNA is broken down or degraded, then it's not so much affected by the PCR technique. They can use smaller sections to sequence. So if the DNA or the RNA is more broken up, then you definitely, and it typically is with FFPE samples, then you typically want to go with the PCR-based sequencing. If you go with the hybrid capture, probably 40, sometimes more than that, 40 to 50% of the time, the samples fail. And with a lot of the companies like Foundation One and Caris, they will go ahead and sequence and charge you, even if it's a poor sample. And then, you just get this report back that says, oh, sorry, we didn't find anything. Mm-hmm. And often that's how, the doctors will say, sorry, we didn't find any targetable mutations. Mm-hmm. So it's a bit of a problem right now. And, with the laser extraction of the tumor cells and the PCR-based next generation sequencing, we're really getting around that, and we're getting a lot more usable samples.
Mm-hmm. Yeah, and we've even had, so please go ahead.
I was just wondering if this was actually accessible for the general public in the public healthcare system.
Most definitely, yes. It's private. But I mean, Michelle, how many companies are doing sequencing these days?
Well, there's two kind of questions here. There's the laser separation process, which is not accessible in public healthcare right now.
Oh, right. Yes. Sorry, there are some places in the States that do have public healthcare based laser resection. Yeah, but we use a private company right now.
Right, because it's not available in Canada. No. Is the fundamental point here. It's as Alex meant. So for starters, it's very new. This whole genetic testing thing and targeted therapy thing for cancer is just over a decade old.
Yeah.
When we started doing this work in Canada over 11 years ago now, we were considered alternative. Like the thought of using genetic testing to find targeted therapies, many oncologists thought of it as alternative and unproven, even though there was tons of evidence for it at that time. So it's still very new. Big systems move slow. So the uptake of new technology takes a while. It's costly. There's so many good reasons for that. Alex mentioned that this type of preparation of tumor sample, which creates a far greater likelihood of a successful test, is expensive. And when we're talking about your life, not really, it's about $1,200. But in contrast to what's done now in standard care with the standard PCR process, or preparation of the sample.
Microscope.
Yes, thank you. Which costs maybe $200 per person. So just the preparation of the sample, there is, if we're thinking a mass scale for a big healthcare system, the cost is quite a difference. But these things are available individually through private access. And then the most important thing about everything we're going to talk with you about today is that your oncologist can use this information. Your oncologist then, whether it's the genetic testing data you gather or research that you gather, it will be used through public health care to treat you. But right now in Canada, this quality approach to making sure you get a good result from any genetic testing you do is not standard.
Okay,
It's
thank
really,
you.
really new.
A great question.
Awesome. Thanks for asking.
Thank you for watching CTOME TV. Subscribe below and stay informed.